tell about the research method. The third is our result and achievements, and the last one I will give is a conclusion. And the first section is in the introduction. I will tell you the Ackermann steering principle, and I will explain why do we use noncircular gears for our research. And the last one is multi-wheel steering mechanisms. Now, let me talk about Ackermann steering principle. Ackermann steering principle is a geometric arrangement of linkage in the steering of a car or other vehicles. It's used to solve problem of steering on the inside or outside when the motor or car turn right or turn left to test out the different circles. And it avoids the tires will slip sideways when following the path around curves. And it's a noncircular, I will tell and explain why we choose noncircular gear to instead linkage. And in the left hand side is linkage. You can see it's very complex, and we have used a large area. And the right hand side is noncircular gears. The noncircular gear have a curvature radius. They will have the contact points here, and the speed ratio will change when the one or two here will turn around. We go with driving gear, and the second gear is driving gears. We use Ackermann steering principle to calculate and give us a relative formula between gear 1 and gear 2, and we use MATLAB software to simulate the equations. And in the noncircular gear, because we don't have many linkages, so we will go set the cost and set the floor areas. And it's the reason we choose the noncircular gear. And you can see the multi-wheel steering mechanisms we use SolidWorks software to simulate. Now I will tell about research methods, pitch curves of noncircular gears, and designing of the multi-wheel steering mechanism. And the last one is tooth profile generations. About pitch curves, we use Ackermann steering principle to generate the relative formula between gear 1 and gear 2. After that, we get the result is angular velocity ratio between two gears, and M21 equal omega 2 per omega 1, and equal divided P2 per divided P1. We use the noncircular gear pitch curves of synthesis principle to get the function of the pitch. We go R1 and R2 is a function of the pitch curves of gear 1 and gear 2. And after we apply the noncircular gear pitch curves synthesis principle, we get the result here. And therefore, we have another result is the arc length of pitch curve of gear 1 from the origin to 360 degrees. S1 equal P M, and M is a modulus and N is a number of tooth. And we also obtain the center distance and provide a pitch curve. And it is to be a multi-wheeled steering mechanism. Here is a center gear we call driving gears. It will control or drive 3 driving gear around it. Each driving gear will drive a wheel by a pulley here. And to get the multi-wheel steering mechanism, to get it, we could divide in two steps. The first step is to consist of the vertical wheel to control the front wheel, and the second step we design to drive the rear wheels, 2 rear wheels. And let me talk about the first substructure. We use geometry method to get the equation here. Beta theta 1 is a function of alpha theta 4, and it's a simple equation. And also we get the Rn to the equation of angular velocity ratio m41 and m14. You can see the equation here. It's the first substructure, and the second substructure is a relationship between theta 2, theta 3, and theta 4. Or it's a relationship between the wheel or wheel 2, wheel 3, or wheel 4. Like the before slide, we have some result here. Beta theta 2 is a function of alpha theta 4, and beta theta 3 is a function of alpha theta 4. And we also get the angular velocity ratio of m24, m42, and m43 between 3 gears. And also we have a function of R1 and R24 of the pitch curves of gear for the first and second structure. And when we set the parameters R equal P and B equal P, the pitch curves R41 will equal the pitch curves R42. And we combine the first pitch curve structure and the second structure, we get it is a pitch curve of steering mechanisms. And when we set the parameter of width of wheel distance, W equals 600, length of wheel distance, pressure, module number of teeth, and the ratio alpha beta, we have the pitch curve of steering mechanism in the right hand side here. And to manufacture circle gears, we use a homogeneous transformation machine, and we use right cutter to cut it. We use mathematical model of the right cutter, and the force to provide the duration of the noncircular gear are generated. And now I will show you our results. When driving gears turn, it will drive 3 wheels. And the second video, you will see clearly. And you can see the rest line is middle line. It is to satisfy the Ackermann steering principle. It's our result, and I will execute conclusion. We use Ackermann steering principle, and we get a smaller turning radius. It will be more compact, cheaper, and more flexible. And the last one is the for Noncircular here built in the three-wheel vehicle can be the same by property choosing the parameter in our research. Thank you for your attention.
Okay, thank you. If there are any questions, comments? I have one question regarding the application in which you want to use.
The application.
Because you said that between the authors, among the authors, there are some industrial partners.
If you apply for a car, wheel of a car or other vehicle to driver, like each will drive the motion of the car or the vehicle.
But not for a particular application.
Yeah, I think if we will develop it, and we will have another particular application. And first we want to apply for the car and the other vehicle.
Okay, I have a question. Would be also extended for cars having 4 wheels, 4 front wheels and 2 front rear wheels? For a normal car?
For lots of car and vehicle, and you mean for other machines or another industries?
So not for high speed?
A lot for high speed. I think it's a problem we will focus and because we I don't clear about the velocity of the car. It can be driver or control. So I'm not sure about it, about velocity.
There are any other questions? If not, thank you.
Thank you.